Hello. Today in class we started talking about the Pythagorean Theorem. The Pythagorean Theorem is a really important geometry tool that we use when dealing with right triangles, and it is the reason we spent so much time last week talking about square roots, because squares and square roots are going to come into play a lot when using the Pythagorean Theorem. So let's just get into it. We're going to skip our video here. So like I said, the Pythagorean theorem itself is used when dealing with right triangles. If we have a right triangle like the one we see right here that's labeled ABC, the Pythagorean theorem is used to find missing sides. So the theorem itself is a squared plus b squared equals c squared. Those variables a, b, and c stand for specific sides of your right triangle. Now, A and B can be interchangeable. They can be either of the two legs here, the sides that connect at the 90-degree angle, but C is always your hypotenuse. So right here, C is always a hypotenuse like we see right here. The hypotenuse is the longest side in your right triangle, and it is always opposite your 90-degree angle. All right, so we're going to put it to use right now. So here we have a right triangle with sides that measure 5, 7, and then our unknown side C. So let's just start by reminding ourselves what the Pythagorean theorem is. It's a squared plus b squared equals c squared. So our first step is to plug in what we know. So 5 and 7 are the legs. That means they could be either A or B, and it really doesn't matter what order we go in. So let's plug in 5 for A. So it'll be 5 squared. And let's plug in 7 for B. So that'll be 7 squared. So 5 squared plus 7 squared will equal C squared. All right, the second step is going to be to go ahead and square the numbers that we can square. So 5 squared is 25, and 7 squared is 49. Our third step is going to be to solve for the variable. So in this case, what we can do first is we can combine 25 and 49, and when we do that, we get 74. So 74 equals c squared. The issue with that is that we don't want to know what c squared is. We want to know what c is. So we are going to have to do step 4, which is to find the square root of 74 to find out what c is. So the square root of 74, we go to our handy dandy calculator here. Is 8.6. That means our missing side here is 8.6. All right. Not bad. So let's do it again. I'll go ahead and clear this ink. We need new ink. With this triangle, we now have an identified side of 9, and we have our hypotenuse identified as 12. We are looking for side B. So once again, it's good to remind yourself of what the theorem is. Start with your formula without plugging anything in. All right, so step 1 is going to be to plug in the numbers we know. So 9 is going to be A. So 9 squared. We don't know B. It's what we're looking for. So it will just stay B squared. C is 12 because the hypotenuse is always C. So now what we have here is 9 squared plus B squared equals 12 squared. Once again, we're just going to square what we know. So 9 squared is 81. So 81 plus B squared equals 12 squared, which is 144. Okay, now we're going to solve for the variable. In this case, to solve for the variable, because 81 is being added to our variable, we have to subtract 81 from both sides. to isolate the variable. So if we were to subtract 81 from both sides of our equation, we would get b squared isolated. So b squared equals 144 minus 81, which is 63. So in order to find out what b is, we're going to have to take the square root. So b equals the square root of 63, which equals 7.9. So that means b equals 7.9. Okay? So in this case, we were finding a or b. So one kind of reminder that you should keep in mind is that whenever you're finding c, you're going to be able to add your a squared and your b squared, and then just find the square root of that. Whenever you're finding a or b, you're going to have to subtract, like we did in this step here, to isolate your variable. All right? Okay. Thank you very much for joining me.